All right, so this is the last page of our notes from section 2.3, which we're talking about quadratic equations in one variable. Okay, so Dante stands on the topmost tier of seats in a baseball stadium and throws a ball out onto the field with a vertical upward velocity of 60 feet per second. The ball is 50 feet above the ground at the moment he releases the ball. When does the ball land? Okay, so a little bit of background information. H, which is representing the height, is equal to negative 1/2 times the force due to gravity times t squared plus v naught times t, where v naught is the initial velocity the object has when t equals 0, plus h naught, which is the height of the object when t is equal to 0. Okay, now some other things to note: that ground level means that t is equal to 0. So we'll separate this like so, like this. Okay, so ground level means t is equal to 0. Okay, if t is measured in seconds and h, which is our height, measured in feet, then our force due to gravity, g, is equal to 32 feet per second squared. Okay, another note: if t is measured in seconds and h is measured in meters, then g, which is our force due to gravity, will be 9.8 meters per second squared. Okay, cool. So what do we know? Dante, I'm going to draw a picture. Okay, put this here. Dante is standing on the topmost tier of seats. So you have these seats. Dante is up here. Don't talk trash about my picture. So we have Dante. Dante is standing up there. And it says that Dante throws the ball out onto the field with a vertical upward velocity of 60 feet per second. So, and it says that the ball is 50 feet above the ground at the moment he releases the ball. So, Dante is standing up there. Dante decides to throw a ball like so. And then we know that from the moment he releases the ball to the bottom, that we know that that height is 50 feet. Okay, so what do we know? We know that our h naught is equal to 50 feet. We also know that v naught is equal to 60 feet per second. Okay, so what does that mean? That means we have that, and we know that we want to find t when h is equal to 0. Okay, so what we have to do, we have to look back up at our formula, because this is our quadratic equation, right? We know h is equal to negative 1/2 times g And remember, we have these two options. But for us, G is measured. We know that we're given our answer in terms of feet, right, per second. So we know that we're in this option here where G is 32 feet per second squared. So we know we need to substitute that in for G. Okay, and we have V naught, which is here, and we have H naught. So we're going to use the fact that we know 60 is going to be here, 50 is going to be here, and we know that we're going to have this 32 right there. Okay, so now let's write it out. So writing this out, we have that 0 is equal to -1/2 times 32 times t squared plus, we know our initial velocity here is 60, so plus 60t plus 50. So that means 0 is equal to 1/2 times 32 is 16, but we're multiplying that by negative. So this is -16t squared plus 60t plus 50. Now, we can look at this equation, this quadratic equation, and see that all of these terms here have a 2 in common. So we can divide both sides by 2 to get 0 over 2, which is 0, equals -16 over 2, which is -8t squared, plus, remember we're dividing by 2, right? So this is plus 30t plus 25. And from here, we can use the quadratic formula to solve. Remember, A is equal to -8, B is equal to 30, and C is equal to 25. So now let's use the quadratic formula. So using the quadratic formula, remember it's -b plus or minus the square root of b squared minus 4ac, all of that over 2a. Okay, and our variable here that we're finding is t, so that's what we're going to call it. So this is equal to negative times b was 30, so -30, plus or minus the square root of the quantity 30 squared minus 4, a was -8, c was 25. All of that over 2 times -8. This is equal to -30 plus or minus the square root of 30 squared is 900 minus, or we're subtracting a negative, so this becomes a positive. So plus 4 times 25 is 100. 100 times 8 is 800. So plus 800. All of this over -16. So this is now equal to -30 plus or minus the square root of 1700 all over -16. And an aside, remember that the square root of 1700 is the same thing as the square root of 17 times the square root of 100, but the square root of 100 is 10. So this is the square root of 17 times 10, or 10 times the square root of 17. Easier on the eye. Okay, so all of that to say, we get this is equal to negative 30 plus or minus 10 times the square root of 17 all over negative 16. And then this means that we have two solutions for t. So either t is going to be negative 30 plus 10 the square root of 17, all of that over negative 16. Or we're going to have t is equal to negative 30 minus 10 square root of 17 all over negative 16. So now we just solve each. So this, notice that there's a 2 in negative 30, 10, and negative 16. So we get this would be negative 15 minus 5 times the square root of 17 all over 8. Okay? Then here, if you enter this into your calculators, be careful with the way you enter it. Wavy equals means approximately negative 0.70. But in terms of what we're looking for, it says when does the ball land? If we get a negative 0.70, that means that we have a time before the ball was actually thrown. That means we have a time before the ball was thrown, which doesn't make sense. So we reject this one because this means a time before the ball was thrown. And we move on to our other solution, and we hope it works. So we have negative 30 minus 10 square root of 17 over negative 16. So simplifying, these terms all have a negative 2 in common. So we're going to divide this by negative 2, this by negative 2, and this by negative 2 to get 15 plus 5, the square root of 17, all over 8. And whenever you enter that into your calculators, you get this is 4.45. So this is our solution, and we can say that the ball lands 4.45 seconds after being thrown. Okay? All right, there we go. This is the last example from class. This is quadratic equations in one variable. Make sure you go try your homework.